Good morning, everyone. It's my pleasure to welcome you here today to the Transient Machine Learning Workshop. This is a workshop that's part of the ACM SIGARCH Visioning series. I'm Karen Strauss, and I'm a researcher at Microsoft and also a ACM SIGARCH executive committee member. We've started to organize the Visioning series as a way to bring the community together to talk about research in computer architecture and future directions. And the Visioning series includes workshops such as the workshop last year, Arch 2030, that brought the community together to talk about computer architecture research itself. This was organized by Louis Sezzi, Tom Wanish, Mark Hill, and with the support of CRA CCC. And the white paper reporting on the output of that workshop is available on the CRA CCC website. This year, we have the Transient Machine Learning Workshop. We'd like to thank Olivier Teman, who did all the heavy lifting to put this workshop together. And starting this year, we're piloting video recording for the workshop, so we intend to make the videos available later for later viewing, also as a contribution to the community. And we would also like to announce that we are putting out a call for proposals, and we'd like to hear from you on what are different topics you'd like to see in the Visioning series. And also, we'd like to see your proposals. So we're putting out in the SIGARCH website, we're putting out a request for proposals that explains how to propose one such workshop. So with that, I'd like to thank Olivier again and the rest of the committee, Louis Sezzi and Joe Emmer, and the support of SIGARCH in putting together the series. Thank you.
Okay, thank you, Karen. So I want to thank actually Karen, Luis, and Joel for being very active and fantastic organizers. I also want to thank them for proposing me to organize that workshop. Basically, it's been actually a fantastic experience. Actually, when I advertised the workshop to the speakers, I mentioned it would be between 30 to 50 attendees, and we ended up with more than 160 attendees. So I think the reason for this number of attendees is because of the fantastic lineup that we have with our speakers, and also because of course, the success of machine learning and how much progress has been made. And I think there is no better testimony to this progress of machine learning that on a number of tasks we are getting at close and in some cases actually even exceed human level performance. And I won't go through the details basically here, but it's basically you can see there is a very rapid progress. So of course, a lot of that progress is primarily attributed to the progress that we have in machine learning algorithms. But some piece of that success as well, and that progress has been attributed also to hardware. And of course, as an architect, I'm biased, so I thought I would actually quote a machine learning researcher basically to say that. So now, as you know, the reason why hardware for machine learning has been so successful is because we have a very special situation here where with just a few primitives, we can implement the many neural networks, which are themselves going to be used to implement a very broad set of applications. So we have, in some sense, this very special case where, because we have just a few primitives to support, we can implement very efficient hardware, and at the same time, the application scope of this hardware is going to be very broad. So we can reconcile flexibility and efficiency. Now, going forward, we are facing a couple of challenges. And the first challenge is because actually of that success of machine learning and so many academics and companies investing on the topic, the algorithmic progress has been very fast, so it's evolving at a very high pace. And of course, the timeline of hardware is very different from the one of machine learning algorithm creation. So it's very important for us architects to stay attuned to what's happening in the machine learning community so we can anticipate as much as possible what is coming up. So that's the first goal of that workshop about trends in machine learning. The second one, which comes with it, is as we have progressed in machine learning, we have a diversification of the primitives that we need to support. And that potentially creates a second challenge to what has been, in fact, the very foundation for the success of hardware for machine learning. So this diversification may make it harder going forward to create architecture which are really efficient. So of course, we have to be very careful not to bridle the innovation in the machine learning community. But at the same time, if we can find a way with the machine learning community here to help them understand what is going to work well for hardware, then we may actually create a nice two-way conversation between the two communities, which can help us actually move forward. And that's really the second goal of that workshop, which is to, as much as possible, try to help foster a conversation between the two communities. So I just wanted to set the context of the workshop, and now we can actually get started. So as I've said, and as you have seen, we have a really remarkable lineup of speakers. We unfortunately had one person, Ruchir Puri, who had to drop out. He was on a multi-city tour in the US. He forgot to take his passport, realized that later, actually yesterday evening, and just couldn't have time actually to make it today for the workshop, and he's really sorry about that. So since we actually had a really packed morning with 6 talks and no break, I just inserted a break for 30 minutes and pulled up a little bit the talk. So these times that you see on the slide, those are the final times. So just a general explanation of how we are going to do the workshop. So the speakers overall have 40 minutes, which roughly should be distributed in 30 minutes plus 10 minutes of Q&A. But I also want to encourage the workshop to be very interactive. So if you feel like asking a question during the talk, please do so. If we have actually too many questions during a talk, I will at some point basically reining the questions so the speaker can have time to finish. And then for the speaker themselves, if there is no question basically during the talk, at 25 minutes, I will basically flash for 5 minutes, saying 5 minutes left. If there are questions, I will do that at 35 minutes, so you know that overall you have 5 minutes left in your slot. So with that, let's get started. So our first speaker is Bill Daly. So I guess Bill doesn't need any introduction, whether it's in the hardware actually or machine learning community. He's the chief scientist and senior vice president of research at NVIDIA. He's also a professor at Stanford who is working on hardware for machine learning. Bill had a very harrowing trip and just a couple of hours of sleep, I think. So please welcome him and be nice to him actually during his talk. Thank you.